All right, so we are looking at the third homework. So we'll go through a few of these. Again, basically, it's just the two sections, integration by substitution, and then also integration by parts. So you're going to be using one of the two techniques. And for a lot of it, they'll even tell you. So here we know it's a U substitution because they say make the substitution. In fact, they even give you the substitution, which in my opinion makes it even a little too easy. So let's go ahead and do a few of these. So number one, we're doing the integral of x cubed times 7 plus x to the fourth raised to the sixth dx. So as mentioned, what we want to do is we want to let u be 7 plus x to the fourth. So then du will be 4x cubed dx. And then divide by 4x cubed. So du over 4x cubed is dx. And again, the only two parts we're really using is this part and this part to transform our integral. So the integral then becomes the integral of x cubed times u to the sixth power times du over 4x cubed. So I'm going to pull the 1/4 out in front. The x cubes cancel. So I've just got the integral of u to the sixth du, which should be 1/4 times 1/7 times u to the seventh plus a constant. And we're going to want to switch back to x's. So we'll have 1 over 28 and then change u back to 7 plus x to the fourth raised to the seventh plus your c. And that is the antiderivative there. Let's go ahead and check that. Okay, so something went wrong. The seventh power, not the sixth. That's my fault. I don't know why I typed 7 as the exponent. 6 is the exponent, rather. There we go. Okay. So we'll probably do number 2 and then skip number 3. 3 is pretty easy. We did one like that in class, I know. We did one like 1 and 2 in class as well, but to my eyes, 2 looks more difficult than number 3. So let's say we have the integral here of x squared, rather. Times the square root of x cubed plus 25 dx. So here we want to let u be x cubed plus 25. And then du will be 3x squared dx. So du over 3x squared is dx. So we can make the substitution now. So we get the integral of x squared times the square root of u times du over 3x squared. So the x squareds cancel. I'll bring the 1/3 out in front. And then the u, rather than writing it as the square root, I'll write that as u to the 1/2 power. And then the antiderivative, remember, we're adding 1 to that exponent and then multiplying by the reciprocal. So that exponent becomes 3 over 2. And then we multiply that 1/3 by 2/3. So we get 1/3 times 2/3 times u to the 3 over 2 plus a constant. And then we want to switch back to x's. So we have 2 over 9 times x cubed plus 25 to the 3 over 2 plus a constant. And that's it. Okay, so like I said, let's skip 3 and 4. They look pretty simple. We'll go ahead and do number 5, I guess. Even though, doesn't look too difficult, but maybe the constants are a little trickier. It's the only thing here. So we have x squared divided by the square root of 0.2 x cubed plus 2.7. Just throwing some decimals at you to make it a little more complicated. So u we still want to let be that 0.2 x cubed plus 2.7. So du will be 3 times 0.2, which is 0.6 x to the x squared, and then divide. So, I mean, you could switch to fractions here, I suppose. 0.6 is the same as 3 over 5, so when you divide by 0.6, it's the same as 5/3. So I don't know. I don't know if that's easier or not in this example. Probably. I just, I prefer fractions, but I'm a math person, so. I forgot the dx, and I forgot the x squared. So 5 x squared on both sides. 5 over 3x squared is equal to dx. And then there's the du. Gosh, I keep writing everything wrong. So 5 over 3x squared times du, and that's what is equal to x squared, or dx rather. So our integral becomes the integral of x squared over the square root of u times 5 over 3x squared dx du. So the x squareds drop out. I'll write my 5/3 in front. And then remember, u here is going to be u to the negative 1/2 when we write that using exponent notation. The 1/2 because it's a radical, and the negative because it's in the denominator. So when you add 1 to the power, you're going to get 1/2 as the exponent, and then you're going to have to multiply by the reciprocal of the exponent, which is 2 over 1. So we're going to get 5 over 3 times 2 over 1, u to the 1/2, plus a constant, which is 10/3 times the square root of 0.2 x cubed plus 2.7, and then plus a constant. Okay, so square root 2x to the third plus 2.7. Constant is there for us, so we can submit. All right, all set. Any questions so far? Okay, then we'll look at this next one. Another substitution, but we've got an exponential function, so we're using a different rule here. We're using the exponential rule rather than, so far that's all we've utilized is the power rule. Essentially our basic antiderivative rules, there's 3 of them. There's the power rule for polynomials and power functions. Then we have 2 rules for exponential functions, and then we have 1 for logarithmic. But the exponential is pretty easy here because we just know that antiderivative of e to the x is e to the x, which is all you need to know. So number 6, we have the integral of e to the x times the square root of 1 plus e to the x. So what we want to do here is let u be 1 plus e to the x. So then du is just e to the x times dx. So du over e to the x is dx. So we have the integral of e to the x times the square root of u times du over e to the x. So the e to the x's drop out, and then this is a pretty simple antiderivative. 2/3 u to the 3 over 2 plus a constant, which should be 2/3 times 1 plus e to the x to the 3 over 2 plus our constant. So that's it for number 6. Constant there, we just need to raise it to the 3 over 2. There we go. So again, pretty simple there. Number 7, we see the log appearing for the first time. That substitution is pretty straightforward because we know if we let u be natural log of x, du will be 1 over x. So here we let u be the natural log of x. So du is 1 over x dx. So x times du is dx. So our integral becomes the integral of u to the 24th over x times x dx. So the x's cancel. And your antiderivative now is just u to the 25th over 25 plus a constant. And if we move back to x's, u was the natural log of x. So it's the natural log of x over 25 to the 25th over 25 plus a constant. Notice on this one, it's the first example. So this probably people have missed this because for all of the first 6 so far, they've had the plus c there for you. But for number 7, for whatever reason, they say use c for the constant of integration. So you have to actually add the plus c yourself here. Okay. Okay, 8 is the last of the substitutions, and then the rest are parts. So we'll do 8, although probably it's not so difficult either. So the integral of t e to the 8t squared dt. So here I would let u be 8t squared. So du is 16t dt. So du divided by 16t is dt. So now we have the integral of t times e to the u times our du over 16t. So the t's drop out, and I've got 1/16 integral e to the u du, which will be 1/16 e to the u plus a constant. Antiderivative of e to the u is e to the u. And then we've got 1/16 e to the 8t squared plus a constant. And again, the constant's there for us, so we don't have to type it for this problem. All right. Okay, so now moving on to parts. So are there any questions on the integration by substitution by anyone? So there's somebody said something in chat. Is our test on the 19th? So our test will be available. I'll make it available today. It just needs to be finished by the 19th. But we'll do the test review on, say, Monday. Or maybe I'll do the recorded lecture on Monday because I did a test review already that's recorded. So I'll have that Monday, and then we'll do, a live version on Wednesday, and it'll be pretty much the same. But if you have any questions, you can ask them then. So hopefully that clears things up. I just need to schedule it. So I'll do that after class. Okay, so back to the homework. So integration by parts, let's look at number 9. So we're doing the integral of 9x natural log of x dx. So when we have the natural log in a polynomial, typically the log is going to be the u, and the 9x will be the dv. So that'll make du 1 over x dx, and v will be 9 over 2x squared. So our integral becomes u times v, so 9 over 2 x squared natural log of x minus the integral of v times du. So we'll have 9 over 2 x squared times 1 over x dx. So you have 9 over 2x squared natural log of x minus the integral of 9 over 2x dx. And then the antiderivative there, because it's a polynomial, it's just going to be 9 over 2 times 1/2 times x squared, right? The antiderivative of x is x squared over 2. So we get 9 over 2 x squared natural log of x minus 9 over 4 x squared plus a constant of integration. So we'll skip number 10 here. It's going to be a similar thing. You're going to let u be the natural log of x and dv be p to the 7th. Or rather, u is the natural log of p and dv is p to the 7th. And it'll follow a similar process as number 9. Let's try number 11. We have an exponential there. So we have the integral of 4 minus 6z e to the minus z dz. So it's kind of the reverse here. When you have an exponential, you want u to be your polynomial part, 4 minus 6z, and we want dv to be your e to the minus z. So du is minus 6 dz, and v, basically we just need to divide by -1, which is the same as by -1, so it's negative e to the negative z. So our integral becomes u times v, so we have negative e to the negative z times 4 minus 6z minus the integral of v du. So we have two negatives there, so those two negatives cancel out, so it just becomes 6e to the minus z dz. So we have minus e to the minus z times the quantity 4 minus 6z. And then the antiderivative here, we just divide by a negative, so that cancels with the negative in front, so it just becomes plus 6e to the minus z plus your constant. So Probably the biggest hurdle on that one is just paying attention to all the negatives. But once you keep track of those, then it's not so bad, really. All right. So that's it for number 11. Number 12, we've got the natural log, and it's divided by x to the fourth. I would say the only thing here is use some algebra to rewrite that x to the fourth. So our integral of natural log of x over x to the fourth dx. The way you want to think about this problem really is natural log of x times x to the negative fourth. And then your substitution, or your your choice of u and dv will be much simpler. So again, when it's a natural log involved, typically that's going to be your choice for u. So u is the natural log of x, and dv is x to the minus fourth. So du is 1 over x dx, and dv is, v will be negative 1/3 x to the negative 3. Adding 1 to the power. Remember, when you add 1 to the add 1 to negative 4, it is actually negative 3. I see a lot of students add 1 and end up with negative 5, but negative 4 plus 1 should be negative 3. So we have our u times v, so that's going to be negative natural log of x over 3x cubed minus the integral of v times du. We have a negative coming from the v, so I'm just going to make that a plus. And then we've got the integral of 1 over 3x cubed times 1 over x dx. So we've got negative natural log of x over 3x cubed plus the integral of 1/3. And so this will be divided by x to the fourth, which is really x to the negative 4, which is how we want to think of it when we're doing the integral. So we've got negative natural log of x over 3x cubed. And then we've got add 1 to the power, it'll be negative 3 again. So really it's going to become a minus because we're going to have to divide by another minus 1/3, or divide by negative 3. So it'll be minus 1 over 3 times 1 over 3, 1 over 9, x to the negative 3 plus our constant. So probably this can be simplified to a single fraction if you want, but I'm just going to leave it as minus 1 over 9x cubed plus a constant. Probably it'll take that. Okay. All right. 13 is pretty straightforward. It's very similar to number 11. I think number 11 is actually more difficult. The only thing is it's a definite integral. So actually maybe number 14 is similar. Let's see, is that harder? No, it's similar. So 13 or 14, any opinions on which I should do? I'll do one of them. Then I'll do number 15. How about we do number 13 and number 15? Again, I will say you can kind of probably cheat on these problems because you can just type them into Desmos, but you do want to do them for practice. That's one of the reasons I mostly have indefinite integrals on this homework assignment. Anytime you have a definite integral, you can just evaluate it numerically on Desmos, which we'll use to check our answer, but it is worth the time and effort of doing it by hand to make sure you know what's actually going on. So here we have the integral from 0 to 3 of x times e to the 6x dx. So we want to let u be x and dv be e to the 6x. So then du is just dx, and v is 1/6 e to the 6x. So our integral becomes uv, so x over 6 times e to the 6x minus the integral of v times du, so minus 1/6 e to the 6x dx, and again this is going from 0 to 3. So we have x over 6 e to the 6x, and then we divide by 6 again, so this is just 1/36 e to the 6x, and we're going from 0 to 3. So you have 3 over 6 times e to the 6 times 3 minus 1 over 36 times e to the 6 times 3, and then minus, well, the first term goes away, that just becomes 0 because we have 0 there, and then we have minus 1 over 36 e to the 0, which is 1. So basically we have 1/2 e to the 18th minus 1 over 36 e to the 18th, and then minus minus, this will just become plus 1 over 36. You could combine this all into a single fraction. I don't know that you need to. I think they want exact answers here, so probably a decimal approximation isn't going to work either. See if it takes that. Please try again. Okay, so did I botch anything up? Probably did somewhere. 0 over 6. So let's check the integration. So u is x, dv is this. du and dv both look correct to me. So I have uv minus the integral of v times du. That's good. Okay, 1 over 6 times 1 over 6, yeah. Excuse me. Oh, I plugged it into 14, not 13. I was typing the answer in the wrong problem. That's an interesting mistake. Just in the wrong dialog box. Okay, there we go. So that fixes that. I just typed it in the wrong spot. Yeah. Okay, so let's go ahead and look at 15. 15, that's all you really want to do is rewrite the bottom part of the integral. So you've got the integral from 0 to 1 of y over e to the 9y dy. So the way to think about this, again, is to rewrite the problem first as y times e to the negative 9y dy. So we would let u be y and dv be e to the minus 9y. So du is dy, and v is negative 1/9 e to the negative 9y. So if we do u times v, we have negative 1/9 y e to the minus 9y minus the integral of v du. We have a negative coming from v, so I'm just going to make that a plus. And then we've got 1/9 e to the negative 9y dy. And again, this is going from 0 to 1. So negative 1/9 y e to the minus 9y. So then we've got 1/9 times another negative 1/9. So we get minus 1 over 81 e to the negative 9y. Then everything is going from 0 to 1. So when you plug in 1, we just get minus 1/9 e to the minus 9 minus 1 over 81 e to the minus 9. And then we want to subtract. When you plug in 0, again, the first term vanishes, and the second one just turns into minus 1 over 81 e to the 0, which e to the 0 is just 1, so minus negative 1 over 81, essentially. So we've got minus 1 over 9 e to the negative 9 minus 1 over 81 e to the negative 9 plus 1 over 81. Again, you could rewrite this in a variety of ways. You could pretty easily get a common denominator. You could throw those e's back in the denominator, but I'm just going to try and punch it in as is. That's, if it does recognize all equivalent forms, there are no prizes for simplification. And there are no rules that instruct you to simplify in any particular way. So let's see if this works. Hopefully you have typed it into the appropriate question. Okay, so all set. So that's it for homework 3. I mean, a lot of integration. The two main techniques that we deal with, substitution and parts. So let me go ahead and stop the recording. Okay. I should probably just don't show this message again.